This is day 17 of Unit 7. So we started with this warm-up today. Take a moment and pause the video to do the warm-up, then play to check your answers. So first, graphing the original equation, y equals 2x cubed minus 1. So if I substitute a few values in here, so I know 0 cubed is 0 times 2 is 0, minus 1, so 0, negative 1. Let me just get my pen here. So 0, negative 1, right there. Putting in 1 cubed is 1, times 2 is 2, 2 minus 1 is 1, so 1, 1, right there. Let's get one more point. So how about negative 1 cubed is negative 1 times 2 is negative 2. Negative 2 minus 1 is negative 3, so negative 1, negative 3 right there. So now I have enough points that I can draw in my cubic. So that's the original f of x. Okay, next we are going to find the inverse. So if I have y equals 2x cubed minus 1, I'm going to add 1. I'm going to divide by 2. I'm going to, so that leaves me y plus 1 over 2 equals x cubed. I'm going to take the cubed root of both sides. And I'm just going to simplify that. So cubed root of 1/2 y plus 1/2 is equal to x. So the cubed root of 1/2 x plus 1/2 is equal to f inverse of x. And that's my answer for the inverse. So then I can fill in some values for x. So I'm going to try, let's see, negative 1 I think would be a good one. So negative 1 times 1/2 is negative 1/2. Negative 1/2 plus 1/2 is 0. Cubed root of 0 is 0. So negative 1, 0 right there. Next, let's see, 1 times 1/2 is 1/2 plus 1/2 is 1. Cubed root of 1 is 1. So 1, 1 right there. And let's see, negative 3. All right, negative 3. So negative 3 times 1/2 is negative 3/2. Negative 3/2 plus 1/2 is negative 2/2, which is negative 1. Cube root of negative 1 is negative 1. So negative 3, negative 1 right here. So then I can see that if I take this cubic and I flip it across y equals x, I'm going to have my inverse graph, something like that, and that's f inverse of x. Okay, now hopefully you realize as you graph the original and the inverse, a relationship that exists between the points. So we had 0, negative 1 on the original. We had negative 1, 0 on the inverse. We had 1, 1 on the original, and we had 1, 1 on the inverse. And we had negative 1, negative 3 on the original, and we had negative 3, negative 1 on the inverse. So the relationship that exists between a function's graph and its inverse graph is that x, y on the original becomes yx on the inverse. So in the future, when you have a problem like this one here, I would actually suggest doing the problem in a little bit different of an order. I would not suggest that you get the inverse equation and then use that equation to get the inverse graph, because what if you make a mistake on your inverse equation? Well, then your inverse equation and your inverse graph are both wrong. So instead, what you probably should do is graph the original and then take those points and flip them and then plot those flipped points. And then you'll be able to tell enough how the original graph looked. You'll be able to tell by visualizing, flipping that graph across the line y equals x. You should be able to tell with those flipped points and you're visualizing the graph flipped, what the inverse graph is going to look like. So get the inverse graph from flipping, then find the equation for the inverse, and then you can check that your inverse equation matches with your inverse graph. And that way, again, if you make a mistake finding the inverse equation, your graph is still correct, your inverse graph and your original graph. So that's how I would suggest doing that type of a problem from now on. Okay, so today we talked about how we could prove that two functions are inverses. So we started with this one from the warm-up and the inverse. So we know that they are because we just found the inverse, but another way of proving them we're going to talk about here. So when you first learned about functions, you probably learned about a function machine. I'm just going to call this function machine f of x, which really just means that there's something going in as the input. It's going into that function machine. It's the function's being applied, and then something's coming out. We also have another function machine for g of x. Okay, same thing. Inputs going in, outputs coming out. So if I'm thinking about inputs and outputs for this first function f of x, let's just say for a moment, let's put 0 in. So when I put 0 in as an input, I'm getting -1 as an output. Well, if this other machine, g of x, is the inverse of f of x, well, we know what inverse means. We know it means opposite operation in the reverse order. So if I then put -1 in as the input, if you think about that, opposite operation, reverse order, that would mean then that my original input should come out as the final output. So let's see if that happens. I'm expecting 0 to come out because that was the original input. So if I put -1 in this g of x function, and we did that a moment ago, 1/2 times -1 is -1/2. -1/2 plus 1/2 is 0. Cubed root of 0 is 0. 0 does come out. Okay, now I haven't proven anything yet. One number example doesn't prove something true always for every number, but just kind of we can see how this works. So instead of putting a number example in, I'm going to put a variable input. So when I put x into the f of x function, the function's applied and my output is f of x. So then if I put f of x in as my input into this other function machine, then I'm applying g of x to f of x because I'm inputting f of x. So I'm basically finding g of f of x. Well, if these are inverses, and we understand what happened here with 0 going in, -1 coming out, -1 going in, and 0 coming out, you hopefully understand that g of f of x, my final output, should be equal to my original input, which was x. Okay? Now, that works both ways. I could start with this function g of x and put x in. So x goes in, out comes g of x. Then I put g of x over here into the f function. So g of x goes in, and out comes f of g of x. That f of g of x should be equal to my original input, which was x, if f of x and g of x are inverses. Okay, so we have really I guess a theorem here that says f of x and g of x are inverses if and only if f of g of x is equal to x, and also g of f of x is equal to x. So they have to both be equal to x, and which means they're both equal to each other, okay, because they both equal x. If and only if, by the way, if you don't remember from geometry or you weren't taught that, if and only if just means I can I can read that statement both ways. So if f of x and g of x are inverses, then f of g of x equals g of f of x. And also flip it around the other way. If f of g of x equals g of f of x, then f of x and g of x are inverses. Okay, so we can use that either way. Here, we're going to use it the reverse way because we're trying to prove that these are inverses. So what we're going to do is we're going to find f of g of x. We're going to find g of f of x. We're going to show that they both equal x. And when we show that they both equal x, we will have proven that f of x and g of x are inverses. So that's our plan of attack. So I'm going to find f of g of x, meaning I'm going to start writing the f function 2x cubed, but the minute I write the x, I'm replacing that with g of x because g of x is going in place of x. So that means 2 times the cubed root of 1/2 x plus 1/2. And that's going to be next my f equation cubed and then minus 1. So I know that cubing a cube root, it undoes that. So I'm just left with what was underneath the cubed root in the first place. And I'm going to multiply that by 2. So 2 times 1/2 x is x. 2 times 1/2 is 1. And x plus 1 minus 1 gives me x. So it's looking good so far. But just because we've gotten f of g of x equaling x doesn't mean we have proven that the two are inverses yet. We need to get g of f of x equal to x as well. So g of f of x means I'm starting to write the g function, so cubed root of, I have 1/2, instead of writing x, I'm putting 2x cubed minus 1 in its place. And then after the x, I have plus 1/2. So I have the cubed root of 1/2 times 2x cubed minus 1. Well, 1/2 times 2x cubed is x cubed, and 1/2 times negative 1 is negative 1/2. And then I have plus 1/2. Well, negative 1/2 and positive 1/2 cancel out, and I'm left with the cubed root of x cubed, and the cubed root of x cubed is x. So because we got f of g of x equaling x and g of f of x equaling x, then we can say that f of x and g of x are inverses. Okay. Next one. So go ahead and copy that. Now, these two equations are much simpler. They're linear, and they're pretty easy to just find the inverse for. So one way that you could prove that these are inverses or that they're not is like we just did, finding f of g of x and g of f of x and showing that they both equal x. Another way, though, that's acceptable for proving two equations are inverses would be to find the inverse of the one, find the inverse of the other, and show that the inverse of the one is the other, and show that the inverse of the one is the other. So that sometimes is a little easier than finding g of f of x and f of g of x. Just depends on the equations. The last equations were more difficult, so it's probably easier to find f of g of x and g of f of x. Here, these equations are rather simple, so it might be easier just to find the inverse of each. So that's what we're going to do in this one. So y equals 2x plus 1, so I'm going to subtract 1 and divide by 2, of course, to solve for x. So I have x equals 1/2 y minus 1/2. So 1/2 x minus 1/2 is equal to y. So I can see that is the other equation. I do want you, though, to show it the other way around. So I want you to show y equals 1/2 x minus 1/2. So I'm going to solve for x. So plus 1/2. And I can see I need to multiply by 2. So I have 2y plus 1 is equal to x, so 2x plus 1 is equal to y, and I can see that that's the first equation. So because the inverse of the first is the second, and the inverse of the second is the first, I know that f of x and g of x are inverses. Okay, so let's try one more. Once again, you could either find f of g of x and g of f of x and show that they both equal x, or you can find the inverse of f of x, find the inverse of g of x, and show that the inverse is equal to the other equation. And with these two, these are a little bit more complicated equations, so I don't know if one way seems easier than the other, but again, either would work. Yesterday in class, we did do one similar to this, finding the inverse of it. So maybe that finding the inverse would be easier just because we've done that more recently. It's up to you. I think in this one, because in class, students really mostly wanted to find the inverse, I think that's what I'll do. I think I'll find the inverse of the one on the left here. But again, the other technique will also work. And both I would accept on a quiz or a test. Okay, so I'm going to add 3. I know that I'm trying to solve for x, that's my goal, and right now it's in the denominator, so I know I have to multiply by x plus 1 to get rid of the denominators. So I have 1 is equal to, remember, you don't want to multiply that out because that's getting further away from your goal, which is to solve for x. So instead of multiplying it out, I'm going to divide both sides by y plus 3. So now I have x plus 1 is equal to 1 over y plus 3. And almost there, I'm trying to solve for x. So subtract 1. And lastly, interchange x with y. So comparing this equation, y equals 1 over x plus 3 minus 1 to y equals negative 1 over x plus 3, I can see that they're not the same. So the minute you find a counterexample, you do not have to, you don't have to do anything else because this is not the same as that, which means I don't have to check G inverse of x at all. I know that G inverse of x is not going to be f of x because I found f inverse of x and I didn't get G of x. So I don't even have to bother any further. So the minute you see that it's not true, that they're not inverses, you may stop. So I can just say, no, they are not inverses. F of x is not G inverse of x. And G inverse, or G of x is not f inverse of x. Okay, so they're not inverses. Now again, if you're trying to prove that they are inverses, and you go through and find the inverse of the one, you should not just stop and say, yes, they're inverses. You should then get the other inverse and confirm that you're getting the first equation. So it's harder to prove that they are inverses than to prove that they're not. And same thing if I use that other approach like we did in the first example, when I do f of g of x and I get x, you can't just stop and say, yes, they're inverses. You have to then do g of f of x and get x as well. Okay, so you have to get x both ways, or if you're finding inverses, you have to find the inverse of the one is the other, and the inverse of the second is the first. But if you're getting something that leads you to say, no, they're not, you do not have to then find the other inverse. So your assignment for homework is pages 2 and 3, problems 11 to 20, worksheet 6, problems 3 and 6 to 11. Notice that this assignment is a little bit different than what was posted on the calendar originally. So follow this assignment, please, or the assignment that's posted on Schoology.